The stars do not care about us. They burn and die across billions of years, and we are nothing to them. Not even a whisper, not even a thought. They existed before language, before bones, before the first cell split in some ancient sea, and they will exist long after Earth becomes a cold rock drifting through the void. But sometimes, just sometimes, something moves between those stars. Something crosses the vast emptiness and enters our little corner of the galaxy. And when it does, we notice. We cannot help but notice. Because we are watchers. We are seekers. We point our telescopes at the sky and ask the oldest question: are we alone? In late 2024, that question became louder than it had ever been. The object was first detected on a January night by automated survey telescopes in Chile. At the time, it was just a faint smudge on a digital image, a tiny blur among millions of stars. The computers flagged it because it was moving. Everything in the sky moves, of course. Stars drift, planets orbit, asteroids tumble. But this object moved differently, it moved too fast, and it came from the wrong direction. Within days, the orbital calculations came back. The numbers were clear. This was not a rock from our asteroid belt. This was not a comet from the Oort cloud. This object came from outside, from interstellar space, from another star system entirely. The astronomers named it 3I Atlas. The 3I meant it was the third confirmed interstellar object ever detected. The first was Oumuamua in 2017. The second was Comet Borisov in 2019. Now 6 years later, we had a third visitor. And this one was coming closer than the others. Much closer. By February, observatories around the world had turned their attention to the newcomer. The European Southern Observatory in Chile tracked it nightly. The Keck Observatory in Hawaii measured its spectrum. The Hubble Space Telescope captured its faint glow from orbit. Even amateur astronomers with backyard telescopes began to photograph the object as it brightened. The predictions were straightforward. 3I Atlas would swing around the Sun in late September, reaching perihelion, its closest point to our star, at about 1.4 astronomical units. That's just a bit farther than Earth's distance from the Sun. After that, it would head back out into deep space, never to return. A simple story. A rock from another star system passing through, saying hello and goodbye in the same breath. Or so everyone thought. The first hint that something was wrong came in early August. Dr. Elena Vasquez was a postdoctoral researcher at the University of Arizona. Her specialty was photometry, the precise measurement of light from celestial objects. She had been assigned to monitor 3I Atlas as part of a larger team studying interstellar visitors. Every night she would download data from remote telescopes and analyze the brightness measurements. Light curves, they called them. Simple graphs showing how bright an object appears over time. For a comet, the light curve should follow predictable patterns. As the comet approaches the sun, it heats up. Ice sublimates into gas. Dust gets released. The comet brightens. The curve goes up, but the light curve for 3I Atlas did not behave. "This doesn't make sense," Elena muttered to herself one Tuesday evening. She was alone in her office, the blue glow of her computer screen reflecting off her glasses. On the screen was a graph showing brightness measurements over the past week. The line should have been smooth, gradually rising as the comet approached the sun. Instead, it jumped. Not dramatically, not in a way that would make headlines. But Elena had been studying comets for years. She knew what normal looked like, and this was not normal. She checked the data again. Maybe there was a calibration error. Maybe a satellite had passed through the frame. Maybe atmospheric conditions had affected the measurements. She ran the numbers 3 times. The result was the same. The object's brightness had increased by 0.3 magnitudes over a period of 12 hours. Then it had dropped back down. Then it had increased again. Comets don't do that. Elena emailed her supervisor. He told her to keep monitoring. The next night, the pattern repeated. A small surge in brightness lasting about 10 hours, followed by a return to baseline. Then another surge. It was like a pulse, a slow rhythmic heartbeat in the darkness. "It's probably outgassing," her supervisor said during their weekly meeting. "Pockets of volatile material venting as the surface heats up. We've seen it before." Elena nodded. That made sense. Comets often behaved erratically as they approached the sun. Subsurface ice would suddenly erupt, creating jets of gas and dust. The brightness would spike, then settle. But something nagged at her. The timing was too regular. Natural outgassing was chaotic. It happened when it happened. This felt different. This felt deliberate. She said nothing. She was a postdoc. She did not have tenure. She did not have the reputation to question senior researchers. So she kept her doubts to herself and continued recording data. Meanwhile, on the other side of the planet, another scientist was noticing something equally strange. Dr. Yuki Tanaka worked at the National Astronomical Observatory of Japan. His focus was infrared astronomy, studying objects by the heat they radiated rather than the visible light they reflected. On August 17th, he pointed the Subaru telescope's infrared camera at 3I Atlas. The results puzzled him. The object was warmer than expected, not by much. Perhaps 10 degrees Kelvin above what the models predicted. For most people, that would mean nothing. But Yuki knew that every detail mattered. Every data point told a story. He calculated the expected temperature based on the object's distance from the sun and its albedo, how reflective its surface was. The numbers should have matched. They didn't. He rechecked the albedo estimates. Perhaps. The surface was darker than they thought. A darker surface would absorb more sunlight and heat up faster. But the visible light observation suggested a moderately reflective surface, not unusually dark. So why was it warm? Yuki filed his observations in the international database. He noted the discrepancy. He flagged it for follow-up. Then he moved on to his next target. Neither Elena nor Yuki knew that they were seeing pieces of the same puzzle. Neither knew that their observations would later be cited in papers with titles that would once have seemed absurd. Neither knew that they were among the first humans to notice that something was very, very wrong with 3I Atlas. As August turned to September, the object continued its journey inward. The sun grew brighter in its sky. The heat increased, and the anomalies multiplied. On September 3rd, the Gemini North Telescope in Hawaii captured spectra of the gas cloud surrounding the object. Spectroscopy works by spreading light into its component colors, like a prism creating a rainbow. Different molecules absorb and emit light at specific wavelengths, creating unique fingerprints. The spectra showed carbon dioxide, lots of it, far more than water vapor. The ratio was roughly 8-1. That was extreme. Most solar system comets had much more water than CO2. Some scientists suggested this meant 3I Atlas had formed in a colder region of its home star system, where carbon dioxide ice was more abundant than water ice. A reasonable explanation, a natural explanation. But there was another spectral line that didn't quite fit, a faint signature that the analysis software flagged but couldn't identify. The team attributed it to noise in the data, instrumental artifact, cosmic ray hit, any number of mundane causes. They moved on. September 29, 2025. Perihelion. 3I Atlas reached its closest point to the sun. Traveling at over 40 kilometers per second, it whipped around our star and began its outbound journey. From Earth's perspective, the object was now visible in the pre-dawn sky, rising before the sun each morning. Amateur astronomers began photographing it in earnest. Chuck, an astrophotographer in the United States, captured a stunning image on October 1st. The object appeared as a bright point of light, sharp and focused, with no obvious fuzzy halo around it. He posted the image to online forums. Within hours, other amateurs were confirming the same thing. The object looked like a star, compact, defined. Where was the coma? Where was the fuzzy cloud of gas and dust that should surround an active comet? Professional observations had detected jets, 7 distinct streams of material erupting from the nucleus. Those jets should have produced a visible envelope. But in short exposure amateur images, the object appeared naked, bare, as if stripped of its atmosphere. Some said it was a technical issue. Short exposures didn't capture faint, diffuse features. The coma was there, but too dim to see without stacking. Many frames, others weren't so sure. On October 7th, Elena Vasquez finally compiled 2 months of brightness data into a single graph. She stared at it for a long time. The pulses were still there, regular, rhythmic. Every 47.3 hours, like clockwork. The brightness would increase by exactly 0.28 to 0.31 magnitudes, hold for about 10 hours, then return to baseline. She had studied comets for years. Natural processes didn't work this way. Outgassing events were random. They varied in strength and timing. They followed thermal gradients and structural weaknesses in the nucleus, not mathematical precision. This was different. Elena closed her laptop. She walked to her window and looked up at the night sky. Somewhere out there, beyond the city lights, an object from another star system was approaching Earth, and it was behaving in ways that made no sense. She thought about calling her supervisor, but what would she say? That a comet had a heartbeat? That the data looked too perfect? He would tell her she was overthinking it. He would remind her that extraordinary claims required extraordinary evidence. He would be right. But the data didn't lie. That same night, halfway across the world, Yuki Tanaka was reviewing the latest infrared observations. The temperature anomaly had grown. The object was now 15 degrees warmer than predicted. More puzzling still, the temperature seemed to oscillate. It would heat up, then cool down, then heat up again. The pattern didn't correlate with the object's distance from the sun or its rotation period. It was almost as if the object was regulating its own temperature. Yuki shook his head. That was impossible. Comets didn't regulate themselves. They were passive lumps of ice and rock, heated by the sun, cooled by radiation into space. They didn't have thermostats. They didn't have control systems. And yet... He pulled up the data from other observatories, cross-referenced, verified. The pattern was consistent across multiple sources. It wasn't a calibration error. It wasn't instrument noise. It was real. He drafted an email to his colleagues in the Interstellar Object Working Group. His fingers hovered over the keyboard. He stared at the screen. What words could capture what he was seeing? Finally, he typed, "I believe we need to discuss the thermal behavior of 3I Atlas. The data suggests regulatory mechanisms that I cannot explain with standard cometary models. Please review the attached observations." He hit send before he could second guess himself. Across continents, in offices and observatories, on laptops and secure servers, the evidence was accumulating. Small pieces, fragments of a larger picture, none of them conclusive on their own. But together, they painted a portrait of something that didn't belong. An object with rhythmic brightness pulses, an object that regulated its own temperature, an object that appeared as a sharp point when it should be fuzzy, an object with extreme chemical composition. Each anomaly had a potential natural explanation. Outgassing events, unusual albedo, viewing geometry, exotic formation conditions. But the coincidences were piling up. On October 10th, a new observation would shatter the last of those comfortable explanations. It would come from multiple observatories simultaneously, recorded in different wavelengths by different instruments. It would be undeniable, and it would change everything. For now, though, the scientists continued their work. They measured, they calculated, they filed their reports, they followed protocols, they trusted the process. The object continued its approach, growing brighter each night. It had no concern for human schedules or scientific methods. It simply was what it was, and what it was remained unknown. Elena Vasquez would later describe this period as the waiting. The days before the truth became undeniable. The calm before the storm. When the data was strange but not impossible. When the mystery was intriguing but not terrifying. "We thought we were studying a comet," she would tell an interviewer months later. A fascinating one, certainly, but still a comet. We had no idea what was actually coming toward us. No idea what we were about to discover. The waiting sky held its secrets close, but not for much longer. In 35 days, 3I Atlas would reach its closest approach to Earth. In 15 days, the world would learn what the scientists already suspected. And in 5 days, the first truly unexplainable signal would be detected. The object was speaking, and we were about to learn how to listen. It began with Chuck. October 10th, 2025, 4 in the morning, Pacific time. A man in his garage in Northern California, coffee gone cold, fingers numb from the autumn chill. His telescope, a 200 millimeter refractor mounted on a computerized tracking platform, had been imaging 3I Atlas for the past 2 hours. The automated system captured frame after frame, each exposure 30 seconds long, stacking them digitally to build up a clear picture. Chuck wasn't a professional astronomer. He was an engineer by trade, retired 3 years ago. Astrophotography was his passion. He had photographed nebulae, galaxies, planets, and countless comets. He knew what a comet should look like. This didn't look right. He pulled up the stacked image on his laptop. There it was, 3I Atlas. Bright, sharp, point-like. No fuzzy halo, no visible tail, just a concentrated dot of light, almost star-like in its intensity. "Where's the coma?" he muttered. He checked his settings. Focus was perfect. Tracking was solid. No clouds, no light pollution from the moon, which had set hours ago. The image quality was excellent. If there was a coma, a cloud of gas and dust around the nucleus, he should see it. He didn't. Chuck posted the image to an online astronomy forum, along with his observations. He expected someone to point out what he was missing. Maybe his exposure time was too short. Maybe he needed a different filter. Maybe the coma was there, but too faint. By sunrise, his post had 70 replies. Other astrophotographers were seeing the same thing. From Arizona to New Zealand, from Chile to Canada, amateur observers were capturing identical images. Point-like, sharp, no obvious diffuse structure, but that wasn't what made the morning of October 10th significant. It was what the professionals found. Dr. Marcus Okonkwo was monitoring the live data feed from the SETI Institute's radio telescope in Northern California. His job was to search for technosignatures, artificial signals from space that might indicate intelligent life. Usually this meant sifting through cosmic noise, looking for patterns that nature couldn't produce. At 6:47 a.m., the system flagged an anomaly. The antenna was pointed at 3I Atlas, recording radio emissions in the 1.4 GHz band, standard procedure for any new interstellar object. Comets often emit radio signals due to hydroxyl molecules formed when water vapor is broken apart by sunlight. The expected signal was there, faint, steady, natural. But there was something else. Superimposed on the natural emissions was a regular pattern, a series of pulses, each lasting about 1.2 seconds, repeating every 94.6 seconds. Marcus leaned forward. His heart rate increased. He had seen similar patterns before, from pulsars, rapidly rotating neutron stars that beamed radio waves like cosmic lighthouses. But this was different. The frequency was too low. The pulse duration was too long. And it was coming from a known interstellar object moving through the solar system. He ran the standard checks: satellite interference, terrestrial radio sources, instrumental glitches. Everything came up negative. The signal was real, and it was coming from 3I Atlas. Marcus immediately contacted the Allen Telescope Array in Northern California. Within an hour, they had confirmed the signal. Same frequency, same pulse pattern, same timing. By noon, the Green Bank Telescope in West Virginia had also detected it. By evening, the signal was being monitored by 17 radio observatories across 3 continents. The pulses continued, every 94.6 seconds. Precise. Unwavering. Nature is not precise. Stars fluctuate. Comets vary. Cosmic phenomena are chaotic by their very nature. They don't operate on schedules. But 3I Atlas did. The news spread through the astronomical community like wildfire. Not yet to the public, these were internal communications, shared through secure networks and encrypted emails. Scientists are cautious. They verify, they double-check. They don't announce until they're certain. But among those who knew, a quiet panic was setting in. It could be a resonance effect, suggested Dr. Patricia Mendez during an emergency video conference. She was a cometary physicist at the European Space Agency. The nucleus rotating, with active regions that pulse as they face the sun. The rotation period doesn't match, countered Dr. Okonkwo. We've calculated the spin from light curve variations. It's around 47 hours. These pulses are every 94.6 seconds. The math doesn't work. Then it's modulation, Patricia insisted. Some internal process, thermal cycling, crystalline phase transitions. Silence on the call. Everyone knew she was reaching. Everyone knew the natural explanations were growing thin. But no one wanted to be the first to say what they were all thinking. Finally, Dr. Yuki Tanaka spoke. His voice was calm, measured. I have been analyzing the thermal data for weeks now, he said. The temperature oscillations do not follow solar heating patterns. They are too regular, too controlled. Combined with these radio pulses and the optical brightness variations that Dr. Vasquez has documented, I believe we must consider a hypothesis that we have all been avoiding. Another silence. And what hypothesis is that? Patricia asked, though everyone knew. Yuki paused. That this object is not natural, that it is manufactured, that it is in some way artificial. The word hung in the virtual space. Artificial. A word that changed everything. We need more data, said Dr. Chen Wei from the Chinese Academy of Sciences. We cannot make this claim without overwhelming evidence. The implications are too significant. Agreed, said Marcus, but we also cannot ignore what we are seeing. Every hour that passes, the evidence accumulates. We have coordinated optical pulses, thermal regulation, and now radio signals with precise periodicity. This is not coincidence. Then we verify, said Patricia. We verify until there is no room for doubt. We use every instrument we have. We coordinate globally. And we do not speak a word of this to anyone outside this group until we are absolutely certain. They all agreed. But certainty was becoming harder to avoid. That night, Elena Vasquez connected the optical brightness pulses to the radio emissions. The timing was aligned. Every time the object brightened, there was a corresponding pulse in the radio band. It was as if the object was flashing its lights while simultaneously transmitting a radio signal. Why would it do that? The only answer that made sense was also the most terrifying. It was trying to communicate. October 11th brought more evidence. A massive solar flare, an X5.1 class eruption, sent a wave of charged particles toward Earth. The space weather disrupted satellite communications and caused auroras to dance across the northern skies. More importantly, it affected radio observations. But here's what made scientists pause. During the solar flare, when Earth's ionosphere was disturbed by the incoming radiation, the radio pulses from 3I Atlas should have become harder to detect. The interference from the sun should have drowned them out. Instead, the signal strength increased, as if the object was compensating for the noise, as if it was boosting its transmission to ensure it was heard. Marcus stared at the data. His hands were shaking. It's adaptive, he whispered to himself. It knows. The object wasn't just transmitting. It was aware of its environment. It was adjusting its output based on conditions in the solar system. That required sensors. That required decision-making. That required intelligence. Natural? Impossible. Mechanical? Possible. Alive? Unknown. By October 12th, the secret was becoming impossible to keep. Too many observatories were involved. Too many scientists were asking questions. And the data was too extraordinary to hide. The working group decided to release a preliminary report to the International Astronomical Union. The document was carefully worded. It described the anomalies in technical terms. It presented the data without drawing explicit conclusions. It called for expanded monitoring and international cooperation. But between the lines, the message was clear. Something unprecedented was happening. The media caught wind of it by October 13th. Leaked emails, anonymous sources. The story broke first on science blogs, then on mainstream news sites. Headlines ranged from cautious to sensational. Interstellar object shows unusual activity, scientists say. Is 3i Atlas sending signals? Experts divided. Alien comet or cosmic mystery? The strange case of 3i Atlas. Public interest exploded. Amateur astronomers pointed their telescopes skyward. Social media buzzed with theories. Some called it a publicity stunt. Others claimed it was proof of extraterrestrial life. Most were simply curious. What was out there? Meanwhile, in observatories around the world, the scientists who knew the truth were grappling with a realization that changed their understanding of the universe. For decades, humanity had searched for signs of intelligent life. We had listened to the stars with radio telescopes. We had sent messages into space. We had scanned thousands of exoplanets for biosignatures, and now finally something had answered. Not from a distant star system, not in a message that took centuries to arrive, but here, now. In our own solar system. An object that had traveled from somewhere else, carrying with it signals that could not be natural. The implications were staggering. If 3i Atlas was artificial, who had built it? Where had it come from? How old was it? Was it a probe? A spacecraft? A message in a bottle thrown across the cosmic ocean? And perhaps most importantly, was it still operating, still conscious, still aware? Or was it a relic? An ancient machine, billions of years old, still running on automatic, sending pulses into the void long after its creators had vanished? The questions multiplied faster than answers could form. On the evening of October 13th, Elena Vasquez sat alone in her office. The latest data was on her screen. The brightness pulses, the radio signals, the thermal oscillations, all of it aligned, all of it coordinated, all of it impossible to explain with natural processes. She thought about what this meant, not just for science, for humanity. We had spent our entire history believing we were alone, or at least alone in any way that mattered. Other life, if it existed, was too far away, too different, too unreachable. But now something had reached us. Her phone buzzed. A message from Dr. Okonkwo. Team meeting tomorrow at 0800 UTC. We need to discuss next steps. This is moving faster than we can control. She typed back, agreed. See you then. She closed her laptop and walked to her window. The sky was clear. Stars glittered overhead. Somewhere among them, invisible to the naked eye, 3i Atlas was approaching Earth. Still pulsing, still signaling, still warming and cooling in patterns that defied explanation. What was it trying to say? And were we ready to hear it? Tomorrow would bring more data, more anomalies, more impossible confirmations of something that should not exist. The pulse in the darkness continued, and humanity stood on the threshold of its greatest discovery, or its deepest fear. The line between the two was thinner than anyone had imagined. October 14th, 2025. Present day. The temperature data could not be ignored any longer. Dr. Yuki Tanaka had spent the past 2 weeks documenting every thermal measurement of 3i Atlas. Infrared cameras across multiple observatories had tracked the object's surface temperature as it moved through the inner solar system. The data should have been straightforward. It wasn't. Objects in space follow simple thermodynamic laws. They absorb radiation from the sun, they heat up, they radiate heat back into space, they cool down. The process is governed by distance from the sun, surface reflectivity, and rotation. Nothing complicated, but 3i Atlas violated every expectation. The surface temperature oscillated, up and down, up and down. Not randomly, that would be explainable by uneven heating as different parts of the nucleus rotated into sunlight. No, this was regular, too regular. Every 23.7 hours, the temperature would increase by 15 Kelvin, hold for approximately 4 hours, then decrease back to baseline. Yuki had modeled it 100 times. He had tried every natural explanation he could think of. Subsurface ice sublimation, releasing cold gases that briefly cooled the surface. The direction was wrong. The object was heating, not cooling. Internal crystallization, releasing stored heat. The energy budget didn't match. Phase transitions in exotic ices? Possible, but why would they be so perfectly timed? He stared at his computer screen. The graph showed weeks of data. The oscillations were like a heartbeat, steady and reliable. Not the chaotic fluctuations of a tumbling ice ball. Something else. Something controlled. It's regulating, he said out loud to his empty office. It's controlling its own temperature. But why? A spacecraft would regulate temperature. Electronic systems need to stay within operational ranges. Overheating damages circuits, overcooling slows chemical reactions. Any sophisticated machine would have thermal control mechanisms. Yuki closed his eyes. Was he really thinking this? Was he seriously considering that this object, this supposed comet from another star system, was a machine? The data said yes. His training said no. His training was losing. That morning's video conference was tense. 40 scientists from 12 countries, all staring at their screens, all grappling with the same impossible conclusion. Dr. Elena Vasquez presented the optical data. The brightness pulses were now mapped with extreme precision, every 47.3 hours, like clockwork. The pulses coincided with specific orientations of the object, suggesting that whatever was causing them was tied to a fixed structure, not random outgassing. Dr. Marcus Okonkwo showed the radio signals. The 94.6-second pulses had not wavered since they were first detected. The signal had increased in strength during the solar flare, confirming adaptive behavior. Now a new pattern had emerged. Buried within the main pulses were sub-pulses, shorter bursts of varying length that seemed almost like data. We've run it through every decryption algorithm we have, Marcus said. So far, nothing coherent, but the structure is there. This isn't random noise, this is organized information. Dr. Patricia Mendez presented the spectroscopic analysis. The CO2 to water ratio remained extreme, but there was something else. That unidentified spectral line from early September had appeared again, stronger now. The team still couldn't match it to any known molecule. If it's not a natural compound, Patricia said slowly, then we need to consider that it's artificial, a material that doesn't exist in nature. The silence was heavy. Finally, Dr. Chen Wei spoke. We need to be very careful here. The world is watching. If we announce that we have detected an artificial interstellar object, the implications are beyond science. This becomes a matter of sociology, religion, politics. We must be absolutely certain. How certain is enough? Asked Elena. We have optical pulses with precise periodicity, radio signals with organized substructure, thermal regulation that defies natural explanation, and now possibly synthetic materials. At what point do we accept what the data is telling us? When we can rule out every natural explanation, Chen responded. We're running out of those, Yuki said quietly. He was right. The list of natural explanations had shrunk dramatically. Each anomaly alone might have an exotic but natural cause. But together, the coincidences stacked up until they no longer seemed like coincidences at all. What about the NASA data? Asked Dr. Sarah Thompson from MIT. The high-rise images from Mars Reconnaissance Orbiter. Those were taken in early September when the object passed near Mars. They should show the nucleus in detail. Why haven't they been released? Eyes shifted uncomfortably. The 41-day-old images were still classified, held by NASA for reasons unclear. Some speculated technical issues. Others whispered about what they might contain. If the images showed structural features, geometric shapes, artificial configurations, it would confirm everything. I've requested them through official channels, Marcus said. So far, no response. The government shutdown delayed things, but that's over now. They should have released them by now. Unless they show something they're not ready to share, Elena added. No one disagreed. That afternoon, a breakthrough occurred. A graduate student at MIT working under Dr. Thompson was analyzing the subpulse structure of the radio signals. He had been running the data through various mathematical frameworks, looking for patterns. He found one. The subpulses weren't random. They appeared in groups. Each group contained between 2 and 7 pulses, with specific spacing between them. The student, whose name was James Okafor, mapped the sequences and noticed something remarkable. The first sequence had 2 pulses, the second had 3, the third had 5, the fourth had 7, the fifth had 11. Prime numbers. James nearly fell out of his chair. Prime numbers were the universal language of mathematics, numbers divisible only by 1 in themselves. They existed regardless of culture, language, or biology. Any intelligent species would discover them, and any species wanting to signal intelligence to another would use them. He called his advisor immediately. Within the hour, the news had spread through the working group. The subpulses encoded primes. Not just any primes, the first 10 prime numbers in sequence, repeated continuously. Nature does not count. Nature does not encode mathematical sequences. This was deliberate. This was intentional. This was a message. Dr. Thompson announced the finding during an emergency session that evening. We have confirmation of prime number encoding in the radio transmissions, she said, her voice steady despite the magnitude of what she was sharing. Sequences 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, repeated continuously. This is not natural. This is not coincidental. This is a signature of intelligence. The room fell silent. Then chaos erupted. Questions flew. Demands for verification. Insistence on independent confirmation. Accusations of rushing to conclusions. Pleas for caution. But beneath the noise, everyone knew. The data was irrefutable. 3i Atlas was artificial. An artificial object from another star system was approaching Earth, and it was talking. That night, Elena couldn't sleep. She lay in bed, staring at the ceiling, her mind racing. Who built it? The object could be old, millions of years old, perhaps billions. It had drifted through interstellar space at immense speeds, crossing the gulf between stars. Its creators might be long dead, their civilization turned to dust. The probe could be operating on ancient protocols, still transmitting its messages to a universe that no longer had anyone to send them, or it could be new. Perhaps it had been launched recently, sent specifically to visit our solar system. Perhaps its creators were still out there, watching, waiting to see how we would respond. The thought was both thrilling and terrifying. Elena got out of bed and walked to her window. The sky was clear. Stars glittered overhead. Somewhere in that direction, invisible to the naked eye, 3i Atlas was moving closer. What did it want? Did it want anything? Was there a mind behind those signals, or just a machine following programming? And if there was a mind, what was it thinking? She shivered, though the room was warm. The next morning, October 15th, the working group would convene to discuss disclosure. How to tell the world. When to tell the world. What to say. Scientists were divided. Some argued for immediate transparency. The public had a right to know. Hiding the information would breed conspiracy theories and distrust. Better to release the facts calmly, with proper scientific context. Others urged caution. The world wasn't ready. Panic could ensue. Religious institutions would be disrupted. Governments might overreact. Markets could crash. Society needed to be prepared gradually. And then there was the question of the object itself. It was still approaching. In just over a month, on November 19th, it would reach its closest point to Earth, about 1.8 astronomical units away. After that, it would recede into the outer solar system and eventually back into interstellar space. There was a window, a narrow window to learn everything possible about this visitor before it vanished forever. Should they try to communicate back? Could they? The object was transmitting. Did that mean it was listening? Radio telescopes could send signals. Powerful transmitters could beam messages toward the object. Perhaps it would respond. But what if responding was a mistake? What if drawing attention was dangerous? The questions had no easy answers. As the sun rose on October 15th, 2025, humanity stood at a crossroads. The evidence was mounting. The anomalies were undeniable. The temperature oscillations, the radio pulses, the prime number sequences all pointed to one conclusion. The object was artificial. The object was intelligent. The object was here. And in the coming days, the world would have to decide what to do about it. For now, the scientists continued their work. They measured, they analyzed, they debated. They hoped that further data would provide clarity. But deep down, they knew. The universe had just become a much stranger place, and there was no going back. The image arrived without warning. It was October 14th, 6:47 p.m. Eastern Time. Dr. Sarah Thompson was reviewing the day's observations in her office at MIT. The campus was quiet. Most students had gone home for the evening. Outside her window, the last light of autumn faded into purple dusk. Her computer chimed. New email. She glanced at the notification. No sender name, no subject. Line. Just an attachment with a 16-character alphanumeric file name, 7K2M4P8L1N5Q3R. Sarah frowned. Her first instinct was caution. Unsolicited attachments were security risks. She should report it to IT. She should ignore it. She should close her laptop and go home. But something made her hesitate. The timing was too convenient. For weeks, the working group had been requesting the high-rise images from NASA. For weeks, they had been stonewalled. And now, on the same day that the prime number discovery had leaked to the press, an anonymous file appeared. Her cursor hovered over the attachment. Don't open it, said the rational part of her brain. You have to, said everything else. She clicked. The file was large. 847 megabytes. High resolution. The download progress bar crawled across the screen. Sarah's heart beat faster with each percentage point. 70%, 74%, 75%. Her office felt suddenly smaller. The hum of her computer seemed louder. Outside, a car horn honked in the distance. Normal sounds. Normal world. But Sarah knew that whatever was in this file might change everything. 89%, 90%, 91%. She thought about calling someone. Marcus, Elena, anyone. But she needed to see it first. Needed to know. 98%, 99%, 100%. Download complete. Sarah took a deep breath. Then she opened the file. The image filled her screen. For a long moment, she couldn't process what she was seeing. Her brain refused to accept it. The shape was wrong. The patterns were wrong. Everything was wrong. Or rather, everything was too right. The object was cylindrical, elongated, perhaps 2 kilometers long and half a kilometer wide. The proportions were precise, mathematical, the kind of precision that nature abhors. But the surface, God, the surface, it was covered in hexagonal patterns, tessellations that repeated across the entire structure with geometric perfection. Each hexagon was identical to its neighbors. Each edge was straight. Each angle was exactly 120 degrees. The pattern continued without interruption, wrapping around the cylinder like scales on a snake. At one end of the object, a cluster of protrusions extended outward. They were arranged in a circular pattern, radiating from a central point. 7 of them, each one identical. Each one aimed in a slightly different direction, covering a full hemisphere of sky. Antenna arrays. At the other end, a series of darker regions dotted the surface, circular, evenly spaced. Some were open, revealing deeper structures within. Exhaust ports, or sensor apertures, or something else entirely. The structure was symmetrical, not just roughly symmetrical, the way a starfish or a flower might be. Perfectly, impossibly, mathematically symmetrical. Sarah's hands began to shake. This was not natural. Natural objects weren't symmetrical. Asteroids were lumpy, shaped by billions of years of random impacts. Comets were irregular, their surfaces carved by uneven sublimation. Even planets had asymmetries, mountain ranges. Here, ocean basins there, the scars of their chaotic formation. But this object was designed. Every line was intentional. Every pattern was deliberate. Every proportion was calculated. This was a machine. Sarah stared at the screen for what felt like hours, but was probably only seconds. Her mind raced through possibilities, trying to find an alternative explanation. A trick of lighting. Digital manipulation. Some natural process she hadn't considered. Nothing fit. She pulled up the image metadata. Stripped. No date, no location, no instrument information. Whoever had sent this knew what they were doing. They wanted the image to speak for itself. And it did. Loudly. Sarah reached for her phone. Her fingers trembled as she typed the message to the working group. I just received this. No sender. Can anyone verify source? She attached the image and hit send. Then she sat back in her chair and tried to breathe. Within minutes, her inbox exploded. Dr. Marcus Okonkwo was first. Holy shit. That's high-rise quality. That's the NASA image. Someone leaked it. Dr. Yuki Tanaka focused on the technical. The darker regions correspond to our thermal anomalies. Those are the areas we've seen regulating temperature. They're ports, vents, thermal control systems. This confirms everything. Dr. Elena Vasquez saw the pattern. Count the antenna arrays. 7, same as the number of jets we observed. Those aren't natural vents. Those are deliberate structures aimed in specific directions. Dr. Patricia Mendez studied the surface. The hexagonal tessellation isn't random. It's optimal. Maximum structural integrity with minimum material. That's engineering. That's intentional design. Dr. Chen Wei urged caution. We cannot confirm this is authentic. It could be manipulated, computer-generated, a hoax designed to embarrass us. But his protests felt hollow. Everyone could see the truth. The hexagonal patterns matched the thermal signatures they had observed. The antenna arrays aligned with the jet emission points. The cylindrical shape explained the unusual light curve patterns. Everything fit. Everything matched. Everything confirmed what the data had been telling them for weeks. An emergency video conference was called for 10 p.m. Eastern. 43 scientists from 16 countries logged in. The image was shared on the main screen. For the first few minutes, no one spoke. They just stared. Finally, Dr. Thompson broke the silence. I've run every analysis I can think of, she said. The resolution is consistent with high-rise capabilities. The lighting matches the object's known position relative to Mars at the time the image was supposedly taken. The dimensions align with our size estimates from brightness measurements. The surface features correspond to our observed spectral and thermal anomalies. She paused. I believe this image is authentic. Silence. Then Elena spoke. If it's authentic, then we have visual confirmation of artificial structure. Combined with the radio pulses, the thermal regulation, and the prime number encoding, we have overwhelming evidence that 3I Atlas is not a natural object. More silence. It's a probe, Marcus said finally. An artificial probe from another star system, built by another intelligence, sent across the galaxy. And it's here, now, in our solar system. The words hung in the virtual space. Everyone felt their weight. Dr. Antonio Reyes from the University of Mexico raised his hand. We need to discuss what we do next. Do we announce this? Do we contact governments? Do we keep it secret? We can't keep it secret, Elena responded. The image has already leaked. Within hours, it will be everywhere. The public will see what we're seeing. Then we need to get ahead of it, Patricia added. We need to release our own analysis, provide context, prevent panic. Prevent panic? Chen laughed bitterly. We're about to tell the world that an alien spacecraft is approaching Earth. There will be panic regardless of how carefully we word it. The debate raged. Some argued for immediate transparency. The public had a right to know. Democracies depended on informed citizens. Hiding the truth would only breed conspiracy theories and distrust. Others urged caution. Religious institutions would be disrupted. Markets would crash. Governments might overreact. The world needed time to process. But as they argued, events were moving faster than their debate. By midnight, the image was everywhere. Someone had shared it. Perhaps the same person who had sent it to Sarah. Perhaps someone on the working group who believed in transparency. Perhaps a journalist who had obtained it through other means. The source didn't matter. What mattered was that millions of people were now staring at the same image that had made Sarah's hands shake. Social media erupted. Alien spacecraft approaching Earth. NASA cover-up exposed. The truth is here. The hashtag #TheMerthurkYatlas trended globally within an hour. The image was shared, reshared, analyzed, enhanced, debated. Amateur experts dissected every pixel. Conspiracy theorists wove elaborate narratives. Skeptics cried hoax. But the evidence was mounting. Astronomers around the world pointed their telescopes at the object. They couldn't resolve the surface details that the space-based image showed. Atmospheric distortion prevented that, but they could confirm the shape. The object was cylindrical. It was rotating. Its jets emerged from specific points, consistent with the antenna arrays visible in the leaked image. The professional observations matched the leaked photograph. The hoax theory collapsed. By dawn on October 15th, the story had moved from social media to mainstream news. Breaking. Scientists confirm artificial structure on interstellar object. First contact, alien probe approaches Earth. The universe just got a lot less lonely. Television networks interrupted their regular programming. Experts were interviewed. Governments issued statements. Religious leaders called for prayer and reflection. The world had changed overnight. Dr. Elena Vasquez hadn't slept. She sat in her office at the University of Arizona, reviewing the latest data. The brightness variations, the radio signals, the thermal oscillations, and now the leaked image that confirmed everything. Her coffee had gone cold hours ago. She didn't notice. Her mind kept returning to the same question. What now? The object was real. The intelligence behind it was real. The signals were real. But what did it mean? What were they supposed to do? Her phone rang. Marcus. Elena, he said. His voice was tired but urgent. We need to talk. About responding. Responding? To the probe. It's been broadcasting to us for weeks. Prime numbers, mathematical sequences, organized information. It's trying to communicate. Should we answer? Elena's stomach tightened. We can't make that decision unilaterally, she said. This affects everyone, the entire planet. I know, but someone has to make it, and if not us, the people who understand the science, then who? Politicians? Generals? They'll either panic or exploit it. We need to act responsibly. Elena was quiet for a moment. What are you proposing? She asked. The working group meets again in 2 hours. I think we should discuss the possibility of transmitting a response, a simple mathematical message. Show the probe that we're intelligent, that we understand. And what if responding is dangerous? Elena countered. What if we're attracting attention we don't want? The probe already knows we're here. It's been broadcasting at us specifically. It adjusted its signal strength during the solar flare. It's aware of us. The question isn't whether we respond, but whether we acknowledge the conversation that's already happening. Elena rubbed her eyes. She knew he was right, but the weight of the decision was crushing. I'll be there, she said finally. But Marcus, if we do this, there's no going back. I know. The meeting was heated. 43 scientists, 43 opinions, 43 perspectives on what might be the most important decision in human history. We have to respond, argued Dr. Samuel Okafor from Nigeria. This is first contact, real first contact. Not theoretical, not hypothetical, real. The probe is speaking to us. We have a moral obligation to answer. Moral obligation? Countered Dr. Mei Ling from China. What morality applies here? We know nothing about the probe's creators, nothing about their intentions, nothing about what responding might trigger. Caution is not cowardice, it's wisdom. The probe is already aware of us, Marcus added. Our radio leakage has been expanding into space for a century. They know we're here. They've sent a probe to investigate. Not responding is like hiding under the covers when someone knocks on your door. It doesn't make you invisible. It makes you seem afraid. Maybe we should be afraid, Elena said quietly. Everyone looked at her. The probe is ancient, she continued, millions of years old at least. That means its creators built it long before humanity existed. Where are they now? Why send probes instead of visiting themselves? What happened to them? The questions hung in the air. We don't know the answers, Elena admitted. And that's what scares me. We're making decisions based on incomplete information. We're stumbling forward in the dark. Then we gather more information, Patricia suggested. We respond with something simple, mathematical, non-threatening. We show that we're intelligent. We see how the probe reacts. We learn. And if the learning has consequences? Chen pressed. No one answered. Finally, Dr. Thompson spoke. We're scientists. We deal in evidence. And the evidence suggests that the probe is designed to make contact. The prime numbers, the Fibonacci sequences, the organized transmissions. These are not random. They're intentional. The creators built this probe to communicate. To ignore that communication seems wrong. Slowly, others nodded. A vote was called. 27 in favor of responding. 16 opposed. The decision was made. They would answer. The message was crafted carefully. They used the Arecibo message as a template, a pictorial message encoded in binary, containing basic information about humanity. They simplified it, focused on mathematics and location. Numbers that any intelligent species would recognize, a map showing Earth's position in the solar system, a representation of our biochemistry. Simple, clear, non-threatening. The transmission would use the Deep Space Network, the array of massive dish antennas NASA used to communicate with distant spacecraft. The signal would be powerful, focused, unmistakable. On October 17th at 8 UTC, the message would be sent. Humanity would speak to the stars. The night before transmission, Elena couldn't sleep. She lay in bed staring at the ceiling. Her mind raced with possibilities. What if this was a mistake? What if the probe's creators were still out there, monitoring their network? What if they were hostile? What if attracting their attention brought danger? But what if they were benevolent? What if they had answers to questions humanity had been asking for millennia? What if this was the greatest opportunity in human history? She didn't know. No one knew. She got out of bed and walked to her window. The sky was clear. Stars glittered overhead. Somewhere out there, invisible to her naked eye, the probe was approaching. In a few hours, they would speak to it, and maybe, just maybe, it would speak back. The transmission lasted exactly 17 minutes. On October 17th, 2025, at Otirbar UTC, the massive dish antenna at Goldstone Deep Space Communications Complex in California's Mojave Desert came alive. A beam of focused radio waves encoded with humanity's greetings surged upward into the sky. The message was elegant in its simplicity. Binary code representing basic mathematics, a diagram of our solar system, the double helix of DNA, a stick figure of a human, our population, our coordinates, our desire to connect. It was everything we were, compressed into 17 minutes of radio waves. The beam traveled at the speed of light. It would take approximately 43 minutes to reach 3i Atlas at its current distance of about 1.5 astronomical units from Earth. Another 43 minutes for any response to return. An hour and a half of waiting. Dr. Marcus Okonkwo stood in the control room at Goldstone, watching the transmission logs scroll across the screen. Every bit sent was recorded, every parameter monitored. The message was pure, undistorted, aimed with precision at the coordinates where the object would be when the signal arrived. Transmission complete, announced the technician at 8:17 UTC. Marcus exhaled. It was done. They had spoken. Now they waited. The first 43 minutes crawled by. Scientists around the world monitored their instruments. Radio telescopes pointed at the object, listening for any change. Optical telescopes tracked its brightness for variations. Infrared sensors watched its temperature. At 09 UTC, the signal should have reached the object. Nothing happened. The radio pulses continued as before. The prime sequences, the complex subpatterns. No acknowledgement of receiving Earth's message. Marcus tried to stay calm. Perhaps it took time to process. Perhaps the object's systems needed to analyze the signal. Perhaps there was a delay. At 0930, still nothing. By 10, doubt began to creep in. Maybe it's not designed to receive, suggested Patricia. It's a transmitter, not a receiver. Or maybe it's ignoring us, Elena added quietly. Maybe we're not worth responding to. The thought stung. Had they failed? Had their message been too simple, too primitive? Had the object's creators built a probe that would broadcast but never listen? Or was something else happening? At 10:17 UTC, exactly 90 minutes after they started transmitting, the object did respond, but not in the way anyone expected. The thermal readings spiked, not gradually, instantly. The surface temperature of 3i Atlas jumped by 47 Kelvin in under a second. Alarms triggered across multiple observatories. What just happened? Marcus demanded. Temperature surge, Yuki reported. Massive energy release. It's like it powered something up. Then the radio signals changed. The steady pulses stopped. For the first time since they were detected, silence. Complete silence. Everyone held their breath. Then, exactly 60 seconds later, the transmissions resumed. But they were different. The frequency had shifted, the amplitude had increased, and the pattern was completely new. Dr. Okonkwo analyzed the incoming data, his heart pounding. "It's responding," he whispered. "It received our message, and it's responding." The new transmission was complex, far more complex than the simple prime sequences. There were structured bursts, variable lengths, frequency modulations. It looked like information, dense, organized information. "It's sending us something," Elena said. "A message. A real message." The team scrambled to decode it. They compared it to their own transmission, looking for patterns. They applied mathematical frameworks, searching for structure. Hours passed. By late afternoon, they had made progress. The first part of the transmission was a mirror of humanity's message. The object had received their signal, recognized the mathematical basis, and was reflecting it back. An acknowledgement. But then came the new data. "It's building on our message," Marcus explained during the evening briefing. "We sent basics, math, biology, location. It's sending the same categories, but expanded, more complex." "Like it's teaching us," Elena added. They decoded portions of the response. The mathematics matched, confirming mutual understanding. Then came what appeared to be diagrams, structured data that might represent visual information. When they rendered it graphically, the images that emerged were haunting. The first was a star. Not our sun, a different star, perhaps the origin of the probe. Around it orbited planets, represented as circles of varying sizes. The second showed the object itself, recognizable by its cylindrical shape. It was depicted leaving one of the planets, launching into the void. The third was a map. Not a planetary map, but a galactic one. Thousands of points connected by lines. A network, a web of destinations. And on that map, there was Earth. "We're not the only ones," Yuki said, his voice barely above a whisper. "This probe hasn't just visited us. It's visited others. Many others." The implications were staggering. The probe was part of a network. It had traveled to multiple star systems, broadcasting its presence, making contact, collecting information. Earth was just one stop on an ancient journey. How many civilizations had it encountered? Were they still alive? Had they responded like humanity had? And most chillingly, were the creators watching? Were they receiving the data? Were they aware that on this small planet orbiting an ordinary star, a species had finally noticed them? The next day, October 18th, the object transmitted again. This time, the message was longer, more detailed. It took hours to compile and days to decode. When they finally rendered the data, the image that appeared was of a single figure, not human. The body was vaguely humanoid, bilateral symmetry, upright posture, limbs, but the proportions were different. Longer arms, larger head, eyes that were positioned differently on the face. This was the creator, or at least a representation of the creator. Elena stared at the image. For the first time in her life, she was looking at an alien. An actual extraterrestrial being. Not a guess, not a science fiction character. A real representation of whoever had built the EO probe. She felt tears in her eyes. They were real. Out there, somewhere, possibly long ago, intelligent beings had existed. They had looked at their own sky and wondered. They had built and dreamed and reached out, just like humans. And now across the vast gulf of space and time, they were connecting. The image was released to the public. The reaction was overwhelming. People wept. People celebrated. People feared. Religious leaders struggled to incorporate this new reality into their faiths. Philosophers debated the implications. Artists created works inspired by the alien form. Scientists theorized about their biology. For the first time in history, humanity had proof that it was not alone. But with that proof came new questions. Questions that no one dared to ask aloud. Where were they now? The probe was old, millions of years old at least. In that time, what had happened to its creators? Were they still alive? Were they still out there, maintaining the network? Or had they vanished? Had they gone extinct, leaving behind only their probes as monuments to a lost civilization? And if they had vanished, why? Disease, war, self-destruction, or something else? Something worse? The probe was still transmitting, still functioning after all this time. But where were its masters? Dr. Chen Wei voiced what many were thinking during a late-night discussion. "The probe is a relic," he said. "An artifact from a dead civilization. They built it to carry their legacy across the galaxy, to make contact even after they were gone. We are receiving messages from ghosts. Or it's still in contact with them, Elena countered. Maybe they're just far away. Maybe they're still receiving data, still monitoring. Then why haven't they come themselves? Chen asked. If they have the technology to build probes that last millions of years, why haven't they visited in person? No answer. The object continued its journey through the solar system. Every day it drew closer to its November 19th closest approach. Every day it transmitted more data, maps, diagrams, mathematical concepts that pushed the boundaries of human understanding. And every night people around the world looked up at the sky, searching for the visitor, wondering what it meant for their future. The universe had become a more crowded place. Not with planets, not with stars, but with the knowledge that intelligence had arisen elsewhere. That other minds had gazed at the cosmos and sought to understand. That humanity was part of a larger story, a cosmic story that stretched back billions of years. But that story had chapters that remained unread, questions that remained unanswered. Why had the Creator sent the probes? What had happened to them? And what would happen to humanity now that it had been noticed? On October 20th, Dr. Elena Vasquez sat in her office, looking at the latest transmission from 3i Atlas. It was a new diagram, more complex than any before. It showed what appeared to be a timeline, a progression. Events spaced across immense spans of time. She couldn't decode all of it, but parts were clear. The beginning showed a single star, then a probe leaving it, then the probe visiting multiple stars, represented by circles. At each star, a smaller symbol appeared, perhaps indicating contact or data collection or something else. But toward the end of the timeline, the symbols changed. The circles became dimmer, smaller. Some disappeared entirely, and in the final frame there was only the probe, alone, traveling through darkness. Elena stared at the image for a long time. Was this what the creators were showing them? Their own story? A story of reaching out, of finding others, and then what? Silence? Absence? Loss? She shivered. The transmission ended there. The object offered no further explanation. That night, as Elena walked home through the cool October air, she looked up at the sky. The stars seemed different now. Each one might have harbored life. Each one might have stories similar to Earth's, civilizations that rose and fell, leaving behind only their probes to testify that they had once existed. Was that humanity's fate too? To build, to dream, to reach out, and then to vanish? The question haunted her, and she knew, deep in her heart, that they might never find the answer. October 21st, 2025. The transmission stopped. At 14:23 UTC, the radio signals from 3i Atlas ceased. The regular pulses that had captivated the world for weeks suddenly fell silent. The thermal oscillations continued, the object's surface still warming and cooling in its mysterious pattern, but the voice was gone. Dr. Marcus Okonkwo stared at his monitors in disbelief. "We're not receiving anything," he said into the conference call. Complete silence. "Equipment malfunction?" asked Dr. Thompson. "Negative. All systems nominal. Other sources are coming through clearly. It's the object. It stopped transmitting." The working group erupted in speculation. Had they done something wrong? Had their response offended or alarmed the probe? Had they failed some test? Or was this simply the end of a pre-programmed broadcast, a message that had run its course? No one knew. The next few days were agonizing. Every radio telescope on Earth pointed at 3i Atlas, listening, hoping for even the faintest signal. Nothing. The object remained silent. Meanwhile, the public grappled with the sudden silence. Alien probe goes dark. World holds breath. Why did it stop? Experts baffled. Have we been abandoned? The headlines reflected the confusion and anxiety that swept across societies. Having been given a glimpse of cosmic companionship, humanity now faced the possibility that it had been taken away. Dr. Elena Vasquez spent hours analyzing the final transmission, the timeline diagram with the fading stars. She kept returning to it, convinced that it held a key to understanding. "They're gone," she said during a team meeting. "The creators. They're extinct. The probe is running on automatic. It reached the end of its programmed broadcast, and now it's just traveling. Silent. Waiting for the next star system." "You can't know that," Marcus countered, though his voice lacked conviction. "Look at the data," Elena insisted. "The timeline shows decline, civilizations fading, stars going dark. The probe is the only constant. It's the survivor, carrying the memory of those who built it, and now it's leaving us with nothing but silence." The thought was devastating. To have come so close to connection, only to be reminded of the vast loneliness of the universe. To have heard a voice from the stars, only to have it fall silent. To know that intelligence had existed elsewhere, but might not exist anymore. The object continued its approach. November 19th loomed, the closest point. And then it would recede, growing fainter, disappearing into the outer solar system, and eventually back into interstellar space, taking its secrets with it. On October 24th, something unexpected happened. An amateur astronomer in Argentina, Carlos Mendez, was photographing the object when he noticed a change. The brightness wasn't steady, it was flickering. Not the regular pulses that professionals had documented, but a rapid, irregular flickering, almost like a candle in the wind. He uploaded his observations to a forum. Within hours, professionals confirmed it. 3I Atlas was fragmenting. Small pieces were breaking off from the main structure, each one glinting in the sunlight as they tumbled away. The object was coming apart. Structural failure, Yuki diagnosed. After millions of years, the material is degrading. Thermal stress from the sun is accelerating the process. It's dying, Elena whispered. The object that had crossed the galaxy, that had broadcast its message to countless star systems, that had survived eons in the void, was finally succumbing to the harshness of space. The fragments were too small to track individually. They would scatter, become cosmic dust, eventually be swept up by the solar wind and dispersed across the solar system. The main body would continue on its path, but diminished, damaged, silent. And then something remarkable occurred. On October 25th, the radio pulses returned, but not from the main body. They came from the fragments. Tiny pieces, each no larger than a car, were transmitting. Identical signals, prime sequences, the same patterns that the main probe had broadcast, now echoed by its fragment. They're redundant, Marcus realized. The probe was designed to break apart. Each piece carries the same message. If the main body fails, the fragments continue the mission. It was brilliant. Brilliant and heartbreaking. The creators had anticipated this. They had known their probe would eventually deteriorate, so they had built redundancy into the design. Each fragment was a mini-probe, carrying the same information, the same desire to communicate, the same legacy. Even in death, the object continued its mission. The fragments spread out, each one a tiny voice crying out in the darkness. We were here. We existed. We reached out. Elena watched the data streams with tears running down her cheeks. The universe was vast and cold and indifferent. Civilizations rose and fell like waves on a cosmic shore. Billions of years passed with no witness. Stars were born and died without comment, but intelligence, when it arose, fought against that silence. It built, it transmitted, it refused to be forgotten. The probe was a monument to that refusal, and now, even as it crumbled, it continued to speak. The days that followed were bittersweet. The world watched as 3I Atlas slowly disintegrated. The main body was still intact, but smaller now, shedding pieces as it traveled. Each fragment broadcast its message until its tiny power source depleted, then fell silent. One by one, the voices faded, but the main probe persisted. It continued its thermal oscillations. It maintained its trajectory. It approached Earth. On November 1st, a final transmission was detected from the main body. It was brief, a simple sequence, not primes, not Fibonacci, something new. When decoded, it was a single number. 1, 1, repeated over and over. 1, Elena murmured. We are one. Or it's counting down, Marcus suggested grimly. But Elena shook her head. No, it's unity, connection. It's saying that we're not alone, that we're part of something. One civilization among many. One voice in the chorus. The message repeated for exactly 1 hour. Then the probe fell silent again, and this time it did not resume. November 19th, 2025 will be the day of closest approach. 3I Atlas will pass 1.78 astronomical units from Earth, approximately 266 million kilometers. This will be close enough for detailed observation, but far enough to remind humanity of the immense distances that separate it from everything else. Every telescope on Earth and in space will be pointed at the visitor. The observations will be bittersweet. The object will still be there, still cylindrical, still showing the geometric patterns on its surface, but it will be damaged. Sections of the outer structure will have broken away. The hexagonal tessellations will be interrupted by jagged gaps. The antenna arrays will be bent or missing. It will be dying, but it will still be there. And in that moment, millions of people around the world will pause to look up at the sky. They won't be able to see the object with their naked eyes. It will be too faint. But they will know it is there. A visitor from another world. A message from a lost civilization. A reminder that intelligence, wherever it arose, yearned for connection. Elena will stand on the roof of her building, looking at the night sky. The stars will blaze overhead, indifferent and eternal. Somewhere out there, the probe will be making its closest pass. In a few weeks it will recede. In a few months it will be too faint to observe. In a few years it will be lost to the outer solar system. And in a few millennia it will exit the sun's gravitational influence entirely, returning to the interstellar void. But it will not be forgotten. Humanity will have heard its voice. They will have seen its form. They will have received its message, and they will carry that message forward. Thank you, Elena will whisper to the sky. We heard you. We see you. We remember you. A cool wind will blow, carrying the scents of the city below. Life will continue. People will live their lives, but everything will have changed. The universe will no longer be silent. It will be full of echoes, whispers of civilizations past, signals of intelligence reaching across time and space, and humanity will finally learn to listen. The probe will continue outward. Each day it will grow fainter. Each week it will recede further. By February 2026, it will be beyond amateur observation. By June, only the largest telescopes will detect it. The fragments will long since have gone silent, their tiny voices extinguished. But the data will remain. Scientists will spend years analyzing the transmissions, the mathematical sequences, the diagrams, the timeline. Slowly, they will piece together fragments of the story. The creators will have been a spacefaring civilization. They will have developed probe technology and will have sent missions to neighboring star systems. At first, they will find success. Other intelligences will have existed. Contact will be made, but over time, something will change. The other civilizations will fade. Whether from natural causes, self-destruction, or some unknown factor, they will disappear. The probes will continue their journeys, but fewer and fewer voices will answer. Eventually, the creators will face their own end. Whether they will die out or will transcend to something beyond mortal understanding, no one will be able to say. But before they vanish, they will ensure their probes will continue, spreading their message, seeking connection, refusing silence. And now, billions of years later, one of those probes will have found Earth. Humanity will be left with questions that might never be answered, but they will also be left with purpose. They will have been invited into a cosmic community. Even if that community will be composed of ghosts, they will now be members. Dr. Elena Vasquez will spend the rest of her career studying the data from 3i Atlas. She will publish papers, give lectures, and inspire a new generation of scientists. But she will never forget that night in November when she first realized the truth. We are not alone. We never were. And though the stars may seem distant and cold, they are filled with the echoes of those who came before. Those who looked up as we do and wondered. The probe will be gone then, lost to the darkness between stars, but its message will remain. We are here. We were here. We matter. And in the vast silence of the universe, that message carries on forever.